Hello, everybody, and welcome. Bit of an introduction, and we'll get things underway. My name is Gary Ray. I'm the Market Segment Manager for Levitt Safety. We also have Alex Hilliker, the Vice President of ChemDAQ, and Pete Ellefson, who's the Senior Technical Representative from ChemDAQ. We met with Alex and Pete about a year and a half ago to discuss partnership in Canada. Quickly learned that our companies have the same philosophy and passion for providing solutions to keep workers safe. The sole focus for ChemDAQ is to eliminate workplace exposure to peracetic acid, hydrogen peroxide, and ethylene oxide. This focus has allowed the ChemDAQ team to become true subject matter in the matters in the experts in the field of sterilant gas monitoring. A big part of providing these solutions is education, and that is why we're here today to discuss chemical monitoring specific to the food and beverage industry you are all part of. Our hope is that you'll find this interesting and informative. There'll be lots of time at the end of the presentation for questions and comments. Please use the chat or put up your hand, and I'll turn things over to Alex and Pete.
Gary, thanks so much. Really appreciate it, and appreciate you and your support, your partnership, and the support of the entire Levitt Safety team. We're proud to be aligned with you and reflect the mission that you have for keeping workers safe throughout Canada. It's really an honor to be with you today. It's an honor to be able to have this conversation because, quite frankly, this topic is something that is not talked about enough. Namely worker exposure or worker safety, rather, from overexposure to chemicals that are used in the food and beverage industry specifically. It's a pretty niche and focused topic, and so it's one that we're happy to be able to shine some light on and explore with you today and into the future. I just want to take a minute at the top here to say we're so grateful to the audience for joining. And for the work that you do every day to keep our food safe. That's something that I don't think team members in the food and beverage industry get enough credit for. And so it's a great privilege to be able to have this conversation with you about how to keep your team safe while you're keeping the food and beverage industry safe for all of us to enjoy. So as Gary mentioned, my name is Alex Hilliker. I'm the Executive Vice President here at ChemDAQ. I run our day-to-day business operations for our instrument division, and I also manage our global partnerships like the one with Levitt Safety. I am incredibly passionate about education and awareness, as Gary mentioned, specifically around exposure to toxic chemicals and how to mitigate risks for our customers and partners in that industry. Events and conversations like this are one of my favorite things to do, so thank you again for being here. I'll turn it over to Pete for a quick introduction. Pete.
Yeah, thanks, Alex. My name is Pete Ellefson. I'm one of ChemDAQ's technical sales representatives. My focus is on the food and beverage side of things. We have multiple segments to our business, but my main concern is food and beverage processing. So again, very passionate, similar to Alex, in the education and awareness side of things, and making sure that you and your folks know about the dangers of peracetic acid and what solutions there are to ensure that you and your workers are safe.
Thanks, Pete, and welcome to those that just joined us from the waiting room. Thank you for joining us today. I'm just briefly going to start with a quick introduction of who we are at ChemDAQ. Some of you that are joining may not be familiar with us. We are based out of Pittsburgh, Pennsylvania, in the United States. As Gary mentioned, we've been partnered with Levitt Safety formally for about a year or so now. So still kind of a new introduction to the Canadian market. And our mission, as you see there on the slide, is to empower our customers to eliminate workplace exposure to toxic chemicals. And usually I kind of say full stop there, right? That's all we do. That's what we're focused on. We're very niche, and we accomplish that mission really in three ways. Through our innovative monitoring and control solutions, our industry-leading partnerships like the one with Levitt Safety, and our superior safety expertise. And when I say superior safety expertise, ChemDAQ goes very, very deep into the chemicals we monitor. Gary mentioned in the introduction, we monitor for three chemicals and three chemicals only. Ethylene oxide, which we're not going to talk about a lot today, but hydrogen peroxide and peracetic acid, which all of you are likely using on a consistent basis. And it's something that we want to help shine the light on. The other thing I like to talk about when I'm talking about who we are as a company and our mission is that word empower. I really like to put a focus on that word because at ChemDAQ, we don't believe in being a transactional company. We want to work with our partners and our customers to help them identify and solve challenges that they have related to chemical exposure. And we want our customers to use our technology and our equipment to better understand their environment, not just for the purpose of understanding your environment, but to be able to make decisions and choices that you can implement in your facilities to keep your team safe. I mentioned earlier we do have a global footprint. We've got more than 600 customers on 5 different continents. We're proud to support some of the world's largest and most respected food and beverage companies. We really take a lot of stock in the responsibility that we have to work with each and every one of these customers. We take it very, very seriously, and we appreciate the partnerships that we do have. So why do folks choose to work with us? Well, first and foremost, we provide safer workplaces. That is our number one priority. We want to help to mitigate the harm from potential overexposure to hazardous chemicals. But we also help to create less risk for our partners and our customers. Less risk to the business in terms of ensuring there's efficiency in your operations, ensuring that you're compliant with standards and regulations that are out there in the industry, avoiding shutdowns and things like that that could be caused by lack of awareness of your environment from a chemical safety standpoint. In addition to mitigating that risk from a worker safety standpoint, of course. And then providing that next level protection in terms of, again, empowering our customers with data and information and partnering with great companies like Levitt Safety to ensure that personal touch and attention to help you identify and solve those challenges at your site. So what are we going to talk about today? We've really got 4 key objectives. We want this conversation to be as practical as possible for you. And the conversation doesn't end here. As Gary mentioned, we're going to take questions at the end. We'll have plenty of time for Q&A. You can throw questions in the chat as we're going through the presentation as well, and we'll try to answer them as we go. But we want you to really make this your own. I hope that you'll follow up, with our team and your representatives at Levitt Safety to learn a little bit more and have tailored conversations for your facilities after this particular presentation. So our first objective, we want to make sure that everybody has a baseline understanding of peracetic acid and hydrogen peroxide. Where and how are they used? Why are these chemicals used? And then what are those hazards and potential exposure risks that are associated with those particular chemicals? Second objective, we're going to talk about some recent research and studies that have been done that highlight peracetic acid use specifically and long-term health effects and safety considerations to make when using that particular chemical. Then we're going to shift into that practical component. We're going to talk about how to take that research, those studies, that analysis, and turn it into real-world things that you can do in your facility to help keep your team safe. And then, of course, we'll spotlight ChemDAQ's technology a little bit as a tool for worker safety as part of an overarching worker safety program for your facility. So I mentioned, today the focus of today's conversation is going to be on hydrogen peroxide and peracetic acid. These are antimicrobial chemicals. They're used to prevent foodborne illnesses, of course, to keep our food safe and also shelf stable. These chemicals are most often used, as you see there on the slide, in facilities like protein processing, aseptic packaging and processing, and then surface disinfection, as well as equipment disinfection. And before we get into the meat of what we want to talk about today, I wanted to start by making sure everybody's on the same page when it comes to definitions when we talk about worker exposure from toxic chemicals. This slide really helps to make sure we're all on the same page because understanding these definitions and these acronyms, I understand it's a little bit of alphabet soup for those of you that are not used to it. So I want to briefly walk through these because understanding this is really how we can understand and ensure that we're below safe levels, and checking airborne concentrations throughout our facilities to ensure safety from these chemicals that we're talking about. So first and foremost, I want to talk about the permissible exposure limit. This is as it sounds, it's the legal limit for what we can be exposed to in terms of a hazardous substance. It's usually expressed in terms of a part per million when we talk about an airborne concentration of a chemical. Now, permissible exposure limits are typically expressed in terms of a time-weighted average. So that's the average exposure that you can be exposed to over a given period of time. And that's broken down further into two groups. A long-term exposure limit. This is typically interchangeable with the PEL, the permissible exposure limit. This is an 8-hour time-weighted average. So think over the course of your typical shift, what's the average amount of chemical that you can or should be exposed to safely? And then to measure the acute perspective of that, there's something called a short-term exposure limit. You may hear this referred to as the STEL. So this is the maximum exposure over a 15-minute time-weighted average. So if there's spikes of chemical exposure, things like that, what are the levels we don't want to exceed over a 15-minute period? And then here in the United States, and I know our friends in Canada adopt this number as well pretty often, the National Institute of Occupational Safety and Health, NIOSH, they put out a level called the immediately dangerous to life or health level. That's the IDLH for short. As it sounds, this is the concentration of a particular chemical that can cause that immediate danger. But I think critically when we talk about this, it's those last couple words there on the definition, or preventing the escape from a given situation. So, for example, you may be exposed to a certain parts per million level of peracetic acid or hydrogen peroxide, which are both irritants that could cause your eyes to sting and water and prevent you from getting out of the room that you're in. You may be nearing the immediately dangerous to life and health level, the IDLH for that particular chemical, which we'll talk about in detail here in a couple of slides. Now, important to remember that a lot of different organizations, both in the United States and Canada, work together to fill in gaps and reference each other to make sure that we provide blanket safety recommendations, guidance, and standards for chemicals that are used throughout really all industries, but the food and beverage industry in particular. So there's two that we typically point out. The American Conference of Governmental Industrial Hygienists puts out an occupational exposure limit that they call a threshold limit value. And then the EPA, the U.S. Environmental Protection Agency, puts out levels that they call acute exposure guidelines, which are typically expressed across 3 tiers, tier 1, tier 2, tier 3. And you might be thinking, why do they do that? Well, it's because I don't think this will be earth-shattering for anybody. Sometimes government agencies move slow, particularly when it comes to establishing safe and legal limits for chemical exposure. And so they will often reference each other and encourage organizations and companies to refer to their partner organizations' levels as authoritative. So, okay, hopefully that wasn't too didactic for you. We're going to get into some of the practical stuff now. Just wanted to make sure that everybody was on the same page with what we're talking about today. I am going to turn it over to my colleague, Pete Ellefson, who's going to talk to you a little bit more in detail about peracetic acid and hydrogen peroxide. Go ahead and take it away, Pete.
Thanks, Alex. So yeah, we'll take a deep dive, like Alex said, into each chemical individually. We'll start with peracetic acid. To start with, the purpose and application of PAA, what is it? For the food and beverage industry, where we see in processing facilities, it's used as a high-level disinfectant, or HLD for short. And it's especially common in poultry, beef, pork, and seafood processing. What it's used in these facilities for, and as you've all seen in your day-to-day, is it's used to kill a wide range of pathogens or bacterias. The big 3 that we're targeting when we're using these chemicals is Salmonella, Listeria, and E. coli. One of the benefits of peracetic acid is its breakdown. So once it's off gas and it's broken down, it actually becomes three harmless byproducts, which are acetic acid, water, and oxygen. So once the off gassing process is complete, it's actually virtually safe for anybody to be around. And probably the largest benefit for the food processing companies and people like yourselves is that it maintains its efficacy even if it's in the presence of organic matter. So it's not going to react differently depending on what it's coming in contact with. As far as the benefits of peracetic acid, we do have some harmful or negatives that come with PAA as well. So the first and foremost, it's a highly corrosive chemical that causes both acute and chronic risks if overexposed. So Alex was just talking about those acute exposure limits, so the short term, but also the chronic or long term effects with the PELs and continued exposure. If you've ever been in one of these facilities, you'll see that this stuff can actually eat through concrete. It can eat through galvanized metal. It can react differently to different metals. So that's where that corrosiveness really comes into play. At very low concentrations, it's going to cause irritation. Where we see that irritation typically is with your respiratory systems, your eyes, as far as eyes watering or maybe some blurry vision, and then skin irritation if you come in contact with it as well. It is something also to be noted that it has been linked directly to occupational asthma, as far as whether it's the cause or kind of an accelerator to occupational asthma. It's definitely something we want to keep an eye on. And most importantly, it's a sensitizer. And what this means that as you're exposed to it longer and more often, those responses that we just talked about can become more aggressive, more repeated, and can become rather drastic, to be honest. With peracetic acid, there's a few numbers that we want everybody to keep in mind through your day-to-day operations. Most importantly, we want to keep in mind that threshold limit value of 0.4 parts per million over a 15-minute average. Now, this is the recommended level by the ACGIH. Here in the United States, it's accepted by OSHA, as well as the USDA and FSIS. Where that translates to our friends in Canada are your provincial and territories regulatory bodies. They look at the general duty clause and where employers have to take reasonable precaution to the health and safety of all of their workers. They're looking at this number to issue citations, make recommendations, and keep track of where your exposure levels are. Another number to keep in mind is that IDLH that Alex had referred to. For peracetic acid, OSHA has accepted an IDLH of 0.64 parts per million. Now, this was recommended by NIOSH. A little caveat to this number, it is under review, and NIOSH is continuing to look at the education and investigations and research on that number to see if maybe there's a better number. But as of right now, that's the number that OSHA has expected as an IDLH. So something to keep in mind as you're looking in your facilities. If you start to see those numbers or you're doing tests or monitoring and that number's popping up or your threshold limit values creeping up, definitely want to look at what our SOPs and different operating procedures are to make sure that we're monitoring that for employee health. Alex, if you want to go back real quick, something else to keep in mind with the EPA limits, it's not as crucial in the plant, but we do want to make sure that what we're putting out of the plant is also safe. The EPA has 3 AEGL or acute exposure guidelines that we follow. Level 1 is just kind of discomfort, irritation. Level 2 is serious, longer lasting health risks. And then level 3 would be actually life threatening. For PAA, the EPA does have 3 levels that are listed for their AEGLs. So their level 1 is 0.17 parts per million over 8 hours. Their level 2 is 0.51 parts per million over 8 hours. And their level 3 is 1.3 parts per million over 5 hours or 8 hours. What's interesting is you can kind of see where that aligns exactly with the threshold limit value from the ACGIH as well as the IDLH from NIOSH. They really coincide. So if you're watching those levels and keeping an eye on them, you should be able to stay within what those regulations are across the board. Hydrogen peroxide is another commonly used chemical in the food and beverage space, more specifically in the beverage processing space. We see this a lot with juice companies, dairy, yogurts, ice cream, and cheese. Where it's used in this space, it has to be food grade. So typically the concentrations we're seeing at or around 35%, not typically exceeding 50%. Something to keep in mind on hydrogen peroxide is that at the levels we're using it, it's odorless, colorless, and tasteless. So while using hydrogen peroxide, it's virtually indetectable for the worker to know whether or not they're being exposed. Some of the side effects of hydrogen peroxide here are, again, similar to peracetic acid, are irritation, but it can also cause burns and blisters if in contact with the skin. So we kind of go past that irritation point. We actually start to see some damage. And hydrogen peroxide is actually a known animal carcinogen and mutagen. This is listed by the WHMIS. There are no humans statistics out there right now, but knowing what it can do to animals and the fact that it's a mutagen, it's definitely something that we want to keep on our radar. As far as the limits with hydrogen peroxide, the two most important ones here are the permissible exposure limit, or the 8-hour time weighted average, which is 1 part per million. That's a really low number. It's definitely achievable, but when you see that that number is so low, we want to make sure that that's a focal point as far as a safety standard. And again, the IDLH here is 75 parts per million. Something to kind of note is that the odorless and tasteless side of hydrogen peroxide continues until we're in the few hundreds ppm. So even when this is immediately dangerous to life or health, or kind of that escape realm of things, we still can't smell, taste, or see what this gas is or what it's doing. So something to keep in mind for your employees. And then, as you can see, hazard communication is regulated. So this kind of aligns globally. So obviously the numbers we're discussing here are from the US, but here in Ontario and in Quebec, both of those values stand. So it's across the board. What we'll get into now are kind of the practicalities of peracetic acid. So we'll kind of make a focus point here. Recently, here in the United States, UC Berkeley and Georgia Tech did a study across the country on poultry and swine processing. And what they were looking for was workplace exposure, health outcomes, what engineering controls looked like, and then at the end of the day, policy development and what to put in place for worker safety. So kind of the reasoning behind this study was OSHA authorized a line speed increase for our plants, meaning that they could run their lines faster to create more yield. On the back end of that, there was a concern as far as worker safety, not only for musculoskeletal, but also for exposure to the chemicals that are used. So here you can see some of the data that they found. Overall, 17.2% of the participants reported respiratory symptoms in the past 12 months. That can kind of be alarming, knowing that many people are showing symptoms. So it kind of emphasizes the fact that we need to get a grip on what they're being exposed to and make sure that we're tracking that. They also emphasized prioritizing ventilation. So that comes from your exhaust systems, your air makeup, and most crucial is the clean air that you're bringing back into the plant. Their highlight was that the clean air coming into the plant for these workers should have negligible to no PAA. And that's where those elevated vapor concentrations are. So depending on where you're at in the facility, PAA could be higher, it could be lower. It's crucial to know where your higher areas are and what you're doing to control that area. And then at the end of the day, we want to make sure that there's an industrial hygiene program that is put in place at all of these processing establishments. That way we're maintaining those exposures under what those short-term exposure limits are. How that translates into the day-to-day, their direct recommendations were that monitoring data is going to support the best practices for minimizing what that residue is on your surfaces. It's going to provide you the ability to ensure that you're compliant with those regulations. And it also highlights the importance of not only monitoring, but the PPE that is available to your employees. So while we're handling these chemicals, we want to make sure that gloves, smocks, different, wearable items are available, but also on the respirator side. Are half masks available or respirators available? In the event of a leak, is there SCBA or scuba available to your team members so they can adequately take care of that issue while still remaining safe? And the only way to set those operating procedures is to have results-driven data that's providing you the accurate numbers, the accurate reasoning behind why you're doing what you're doing. As far as managing chemicals in the food and beverage space, it's kind of a no-brainer. It's kind of obvious to most people and probably to you guys, but we want to mention it still, is that it's crucial to provide your team members with the information that is needed while using these chemicals. That starts with safety data sheets or SDS sheets. Every chemical that you guys have in your facility, you're going to be provided an SDS sheet. We want to make sure that that's available to your employees so that they know what they're using, what the risks associated are, and how to properly handle those chemicals. On top of that, communication is key. We want to make sure that all team members know, in the event of emergency, but on top of that, just day-to-day use, what is the proper plan, written, specific, available to the workers so that they know what the next step is while they're using or evacuating from these chemicals. And then on top of that, all chemicals have to be labeled. They come labeled from your manufacturers, but if they're being moved into other totes or different exchange areas, if they're being put into this bottle or specific uses in the plant, we want to make sure that those containers are also labeled. That way everybody knows what's going on in that area. The easiest way, and ChemDAQ will always recommend this, is monitoring. Now, there are two types of monitoring that we look at. There's adequate monitoring, and then there's inadequate monitoring. Inadequate monitoring would be what you see in front of you. The most important thing, especially with PAA, is relying on odor as an indicator. We highly recommend against this. The direct reasoning is what we call olfactory fatigue. So as you're in these environments, as you're using these chemicals for prolonged amount of times, you start to build up what's called olfactory fatigue. And what that is it's your body and your brain getting used to the environment that you're in. So when you first start working with PAA, you may be rather turned off from it, the smell, the side effects, the irritation. But as you're prolonged to it more and more, you become used to it. You don't notice it as much. So even at those low levels, as you start to get used to it, you're not going to know when you start creeping up into those areas where maybe it's dangerous or immediately dangerous. And we want to make sure that that doesn't happen. On top of that, we can't rely on visual inspections. When you look at hydrogen peroxide or PAA, both are in gaseous state. You can't really see it. But on top of that, if we're only looking for leaks or exposures, we may miss something. It's easy to see whenever water is pouring out of a line, but if you had a tote dump and nobody's there and it's off gassing into the air, people could be being exposed in rooms near or hallways, and there's no way to tell. By monitoring, you're going to be able to know what's going on in that space. And that's where we'll kind of get into where our recommendations come from, is that we recommend continuous monitoring systems as a tool of safety. So your regulatory bodies in Canada your provincial occupational health and safety authorities, they all recognize what these exposure limits are to PAA and hydrogen peroxide. By recognizing it, they're also telling you that you need to do something about that. So monitoring those airborne concentrations is crucial to make sure that you're within those occupational exposure limits. We recommend real-time monitoring. It's going to give you a real-time number of what's going on in that space, as well as your averages. But it's also going to give you audible and visual alarms so that you have cues that tell you as you're getting into either a danger zone or an actionable level, so that you can properly keep your team members safe. One of the other benefits are that it's easily integrated into your control systems. So whether that be an exhaust fan or ventilation system, or go in deeper and have this built into your existing BMS or PLC system, you can really see what's going on with those chemicals at any point in the facility. And then why it matters most is, again, back to Alex's big three, our number one priority is, the safety of your workers. We want a safe workplace. So in the food and beverage production, a single chemical incident can cause, not only harm to your team, but it's going to disrupt operations. If these levels are too high, if they go above what those regulations are, you could have costly shutdowns. You could have downtime. You could have waste of product. So it goes even deeper than just the safety of your team. It goes into the safety of your operation. It could also jeopardize your product integrity. We've seen it numerous times here in the States. A listeria or salmonella or an E. coli outbreak. Not only can it cause harm to the consumer, but it causes harm to the brand. It's a lot of backlash in the public eye. It's a lot of litigation. It's a lot of cost. So by using these chemicals, monitoring for them, and controlling those levels, we're able to control that compliance issue and make sure that it's not costing you where it doesn't need to cost you. And at the end of the day, we want to make sure that people aren't waiting for a problem to happen before we're having an action plan in place. By doing that, we recommend chemical monitoring as a part of your safety and your quality assurance strategy. It's going the extra mile. Again, it's that general duty clause. And at the end of the day, it's doing what's right. At this point, I'll turn it back over to Alex. I hope you guys learned something today. I hope it was interesting. Kind of open it up for questions and open comments, discussion.